The topic of this video is to graph polar graphs named Limacons. The Limacon is similar to the cardioid, except these two numbers are not the same. So notice how we use a variable A and a variable B, variable A and a variable B. I'm going to use the first example will be 1 plus 3 cosine theta. For angle 0, cosine of 0 is 1. 3 times 1 is 3, plus 1 is 4. So I'm going to graph 0, 4, and it's going to get all kind of tiny down here. So I'm going to spread out my radii a little bit. So I'm going to go every other one. This will be a radius of 1, radius of 2, radius of 3, radius of 4. And then it'll be a nice picture. So 0, 4 is the first point. Pi over 3 will give me 2.5. So at angle pi over 3, I'm going to go out to 2.5. At pi over 2, I'll have 1. So the curve is going around this way. At 2 pi over 3, I'll be at -0.5. So 2 pi over 3 is this angle, and it's going to go -0.5. So I'm going to go in this direction, -0.5. So it has swooped around, and it's actually going to pass through the origin. Pi gives us -2. So pi is the angle directly to the left, but we're going -2, so we're heading back this way. So notice how this curve is like coming back on itself already. 4 pi over 3 is -0.5. This is your 4 pi over 3 angle, and -0.5 would be here. You should start seeing symmetry now. We're working with cosine. 3 pi over 2 is +1. Back through the origin to hit 1. 5 pi over 3 is 2.5. So 5 pi over 3 is this angle. Here is 2.5. And then we're headed back to the starting point. 2 pi is going to give us 4. So here we go right here. This is a very interesting curve because it comes back around on itself. So you have this inner loop. So we're going to talk about that inner loop in calculus. On the AP test, we're going to ask about perhaps the area inside the loop or the area inside the limacon but outside the inner loop. So it becomes important to know when it crosses the pole. Type that in, 1 plus 3 cosine theta, and see that graph as we just graphed it. Now the interesting part about this is we had a 1 plus 3 cosine theta. What if I had written it the other way? What if I had a 3 plus 1 cosine theta? So let's enter that in, 3 plus 1 cosine theta. You would get a graph that looks like this. There is no inner loop. That looks very close to circular. That could be like a circle, but the point is, when the number, the constant out here, is smaller than the coefficient, you end up with that inner loop. When the constant is larger than the coefficient, you will not have an inner loop. We're going to try 1 plus 2 sine theta. Here are the angles I like to use with sine. When theta is 0, I'm going to get 1. And then when theta is pi over 6, I'll get 2. Pi over 2 will give me 3. 5 pi over 6 will give me 2. Pi gives me 1. 7 pi over 6 is 0. 3 pi over 2 is -1. 11 pi over 6 is 0. And 2 pi gives me 1. I'm interested in looking at these one at a time with you so you get used to graphing it by hand, so you know when it starts, the curve starts, when the curve ends. That'll be important when you're finding area inside the curve because you're going to set up an integral and you'll have to know the lower bound and upper bound of the integral. And knowing how the Limacon graphs will help you do that. So I see that my largest radial value is 3, so I don't need to keep it all down here. I could pretend this is a radius of 1, 2, and 3. I could use the whole graph for this problem. 0, 1 will give me a point here. Pi over 6, 2 is there. Pi over 2, 3. So you know we top out there at 3. 5 pi over 6 is over here. Pi 1. So try to bring that around. And then we're going to see something here. Is this going to look like a circle, or is it going to have an inner loop? Well, the constant is smaller than this coefficient. So that means I'm going to have an inner loop to this Limacon. So let's keep going. I ended at pi, so I'm going to go 7 pi over 6, which is this angle here, is going to put me at the pole. I get 0. 3 pi over 2 is straight down, but it's -1, so I'm going to graph here. So you can see how this would come around inside of the original graph. And then I need 11 pi over 6 brings me back to 0, and then 2 pi brings me back over there to 1. We can check it, 1 plus 2 sine theta, and see what we get. Okay, looks the same. Another observation, you could practice on your calculator. Instead of a plus sign, you could put a minus sign. You could get one like that. So, did you expect this to happen? Maybe you expected the curve reflected over the x-axis, but did you notice how it graphed? When you go to set up your graph in the y equals menu, make sure your toggle switch is on this circle with a line following it. That I'm just toggling right and left to find that. And by having that feature on, when you go to graph, you can watch the direction in which it is being graphed. And that will help you decide how to set up your mathematics later. So practice doing that also. I like to look at a couple others. This is a sine graph where I have the constant is smaller than the coefficient. Maybe I should try a constant, I'll put a 3 there, a constant bigger than a coefficient. And see, now there's still a minus there, so it's going to be flipped over the x-axis. And there you go. Probably want a little more view of that. So you notice there's no inner loop because the constant was bigger than the leading coefficient. It's just kind of a bump in there, not even maybe a slight dimple. So I'm going to look at 2 plus 3. Might need to max, change my y max. So you just keep putting them in. So you get, did you expect an inner loop on this one? So just keep putting them in and take a look at what you're getting so you get used to what they look like. That is the end of the video on Limacons.